Hey guys, and welcome back to another YouTube video. In this video, I'm going to be showing you how you can create a neural network that classifies images of malaria cells in Python. It's going to be a neural network, like the convolutional neural network, with uh, like a pretty dense convolutional layers. You can see we have one, two, three convolutions. So yeah, it will classify whether the people are parasitized or infected. And yeah, it's a very good neural network. The dataset for this neural network was actually pretty large, but I literally just deleted almost all the images from it. The reason was they are pretty difficult to process, so that's why. So let me actually show it to you. I had downloaded this dataset quite a long time ago, so you can just search it out on the internet and download this dataset for yourself. So let me actually put my PyCharm projects. So here in val, you can see these two folders, parasitized and infected. I have a bunch of pictures, and yeah. So as always, I'm going to be using TensorFlow. The reason why I'm using TensorFlow is because that's the module I really like. I don't know PyTorch and sklearn. I know it, but it's very bad. It's not that powerful. So yeah, from actually import TensorFlow as df from TensorFlow import errors, import OS, import CV2, from matplotlib import iplot as ELT, then import numpy as np from TensorFlow dot keras dot pre-processing image. I need to import image data generator, and from TensorFlow.keras dot preprocessing dot actually not dot import image. So we got our lava imports, and we have a look over here. Okay. So what I'm gonna do is grab my train image and grab the image data generator. Now let me have a look at its properties. Uh, we wanna grab the rescale property of it. So rescale. You can see it, there are tons and tons of properties. You can choose horizontal flip also. Fill. We obviously want to grab its rescale property and divide it by 255. Now we actually want to make a dataset out of it. The train dataset is equals to train image dot flow underscore from underscore directory. Inside we can pass in a ton of parameters. It's going to search over here. Flow from directory. Okay, I think it's not available. Whatever. So I'm just going to take the path of the base directory. The reason why I'm not like exactly explaining how this works is because I already have a ton of neural network machine learning tutorials on my channel. If you want to like learn the basics, I would recommend you check out my first and second videos on my first video, which I've ever posted on my channel about machine learning. Then you check out my video of rock paper scissors, and you check out my video of COVID cells. Then you'll be good to go, and you'll be able to follow along, and you will actually understand what I'm doing. So now I'll specify the target size, so the size we want to scale our images to 200 by 200. I just go with that. That size of 15 and class mode of binary. Alright, so now I'm going to specify the class names as equals to parasitized and uninfected. Uninfected. Now we gotta specify the model, so model is equals to keras dot um, sequential. And there you go. I didn't mean to open that app. I'm just going to search over here for conf 2D. Right. Didn't mean to open this app. Close it. No results found. Alright, don't worry. I'll get it over here. So keras.layers.conf 2D. Let's see if it comes over here. Conf 2D, there we go. So you get filters, content size, strides, padding, data format, dilation, rate activation, content initializers, bias constraint. Let's see what are the defaults for that. Alright, so I'm not going to be adding more parameters. Activation of value, keras.layers.conf2d 64 by 3 with a activation function of value, keras.layers.conf2d, actually not conf2d, max pooling 2d 2 by 2. Let's see, can I give it some other thing? Pooling, so strides, padding. Strides, I think it's 1 minute. I don't know. I could probably Google it, but I'm not connected to the internet. So now keras.layers.conf2d 128 by activation. The activation equals value. Now I've not given this layer max pooling in my original neural network, but I'm gonna give it in this one. Keras.layers.max pooling 2D 2 by 2. Keras.layers.tens. I'm sorry, first we gotta go through a flattened layer. Um, Flatten, and now we want last layer, so keras.layers.tens to activation will be softmax. Since we are doing single label classification, I'm using softmax, otherwise I will use sigmoid. So you got a neural network. Now model.compile, optimizer as Adam, loss as sparse, categorical, entropy, metrics as accuracy, model of fit, train dataset, and epochs. I'm just gonna do 5. Alright, let's just run this program. See if it works. So I'll be back once the code runs. Alright, so I'm back. I'm sorry I was gone for a while. Um, I got an accuracy of 89.53%. I actually ran into an error. The activation will be softmax, not. I spelled it incorrectly. So yeah. So other than that, everything was correct. If you get rid of this max pooling, you will get an accuracy of 90%. Since we have not done that and I've got a 90% accuracy. So yeah, we can increase the epochs, leave around batch sizes. So that's it for this video. I hope you enjoyed it. And play around with this neural network. Give me a 100% accuracy. Comment down below. If you could get to that accuracy, I will like heart it. I heart all of my comments. I will actually feel that people actually take some knowledge from my videos. So I hope you enjoyed this video. Comment down below what else I should do with machine learning. I'm also going to be implementing some text classification machine learning models these days. I'm still working on it, like how to make RNNs, deconstructed neural networks. I think that's what it stands for. Still working on it. I'm not good at text classification, so that's why. But I'm trying to do my. I'm doing my best, and I hope I can do that so I can make a video on it. So yeah, so that is it for this video, guys. I hope you enjoyed it, and until the next time we meet, bye bye.